All right, so now we're going to begin our unit on circles. This is a pretty big unit. There's also lots of formulas. If you're just taking the class, you're not going to have to remember the formulas. But if you are one of those lucky individuals that get to take the SOL, you guys will pretty much have to memorize these formulas. They're not going to be given to you on your SOL. So just keep that in mind if you're one of those people that are going to have to take the geometry SOL. So I want you to recall that a circle is the set of all points in a plane that are equidistant from a given point, called the center of the circle. So equidistance from a given point. Equidistance just means they're all the same distance from the center. A circle with center C is called circle C, or we make a little symbol there that looks like a circle and then the letter that's in the middle. The interior of a circle is the set of all points inside the circle. So if this were our circle, everything in blue would be the interior. The exterior of a circle is the set of all points outside the circle. So the exterior would be, not that little piece. Oh, come on. Why don't the highlighter get erased? But, yeah, there we go. We'll just make that a little bit bigger. Now, granted, my circles are not perfect, but you get the idea. Interior, exterior. We have a bunch of different lines that can be associated with a circle. A chord is a segment whose endpoints are points on the circle, and there's our example of a chord. A diameter is a chord that goes through the center of the circle. So notice that a chord does not go through the center, but the diameter does go through the center. So if you look down here at this circle, this red line that I just highlighted, that red line is your diameter. A radius is a segment whose endpoints are the center of a circle and a point on the circle. It's really important that you remember that the diameter of a circle equals 2 of the radiuses, okay? That's a formula that you've learned, but it's been a while since you've used it. You're going to have to use that formula in some of your IXL assignments today, and you're also going to have to use the circumference formula, which is C equals 2 pi r, okay? So those are two formulas you're going to have to know for your IXL. A secant is a line that intersects a circle and 2 points. So a secant is like a green line right there. It's just going to go through the circle, and it can go anywhere through the circle. It could also go through the diameter. A tangent is a line in the exterior of a circle that intersects the circle in exactly 1 point. The point is called a point of tangency. So right there, that tangent line touches in exactly 1 point. Tangent lines are extremely important in practical applications. They're super important. So this first example is we have the circle L, and all I'm doing is just labeling the different parts. So the chords are JM and KM. So JM is a chord, and so is KM. So those are the two chords. The secant is JM. All right, because it actually goes through the circle because of these little arrows on the end. A tangent is the line M. All right, I want you to remember that in order to name a line, you have to use 2 uppercase letters or 1 lowercase letter. If you had to label the diameter, well, as you can see, here's the center, and the only thing that goes from one end of the circle to the other end of the circle would be segment KM. So KM is the diameter of the circle. Oh. And now the radii. Radii is plural for radius. The radius, there can be multiple ones. All right, so we have a whole bunch. We have JL, we have ML, we have KL. So anything that touches that center and goes to the edge of the circle can be a radius. We could have a bunch more. See all of these that I've got in this highlighter? All right, they're kind of like the rims on a car or the spokes in a wagon wheel. All right, those were all radiuses or radii. All right, tangents. So here's the important thing about tangents. So on the left-hand side here, if a line is tangent to a circle, then it is perpendicular to the radius drawn at the point of tangency. So you can see in green where I've marked where the right angle is. So in this example, you know that you have a radius and a tangent, then you have, if you know that the radius is tangent, then you have a right angle. So over here on the right-hand side, if a radius is perpendicular to a tangent of a circle, then the line is tangent to the circle. So in the red side, if you know there is a right angle, then you can say that that line is tangent to the circle. So here's the difference. The green circle, the green side, we know that the line is tangent to the radius. That makes the right angle. On the red side, we know that there is a right angle there, so that means that line is tangent to the radius. Those are two ideas that just go hand in hand. And the reason that it's so important is because we can use that property to figure out some missing parts of our circle. So in example 3, AC is tangent to circle B at point C. That means I've got a, well, I don't want to use the highlighter. That means I've got a right angle. Wow, it looks like I've got a triangle. I have a triangle with a right angle. That means I can use Pythagorean theorem. See, I told you that Pythagorean theorem would be the best theorem ever, and I told you that triangles would never go away. I was serious when I told you those things. So Pythagorean theorem says the hypotenuse squared is the leg squared plus the leg squared. So 13 squared equals 12 squared plus BC is what I'm looking for. Let's get well, it's not how I wanted Desi to get fired up, but let's get old Desi fired up. 13 squared equals 12 squared plus x squared. I'm going to zoom out a little bit. Remember, we're taking the positive value, which is 5. So x is going to be 5. The next problem, FE is tangent to circle D at point E. Find DE. Same thing. We're finding DE, which is the radius. So in order to find the radius of the circle, we're using a tangent line. We're using these tangent lines, okay? So same thing. 17 squared x squared plus 15 squared. So I'm going to go over here and I'm just going to retype some of it. And that should be a 15. X is 8. So the radius is 8 in example 4. Okay? So good old Pythagorean theorem. It's never going to go away, ladies and gentlemen. So now we're trying to verify that these lines are tangent. So in the first two problems, we were told that the lines are tangent, which means it makes a right angle. And these, we're trying to prove that those lines are tangent. Well, in order to prove that the line is tangent, you'd have to prove that you got a right angle there. How do you prove that you got a right angle? Good old Pythagorean theorem. So I'm going to say 15 squared has got to equal 9 squared plus 12 squared. So let's see what happens. Now you got to type this a little bit differently into the calculator. This is the one where you've got to type 15 squared by itself, because that's the C by itself, and you get 225. And then I'm going to type in 9 squared plus 12 squared and get 225. All right? So this is yes. There is a right angle. All right, if I tried to type that all on the same line, this is what's going to happen. Am I getting anything? Is anything popping up? No, nothing's going to pop up because you don't have an X in your problem. So this is one where you've got to separate the two so you can see what's going on. So again, how can I show that PR is tangent to circle Q? There's got to be a right angle. So the right angle should happen here. So that means that 29 is going to be the hypotenuse, and that 20 and 21 are going to be my legs. So 29 squared is 841. And now let's see what 20 squared plus 21 squared gives me, 841. So yes, PR is tangent to circle Q. Whew, we've done a lot so far. Let's keep trucking. Now we're going to talk about our ice cream cone theorem. If two segments from the same point outside of the circle, so there's my point outside of the circle, if they're tangent to the circle, then they're going to be congruent. So those two lines, RS and TS, are going to be congruent. And here's how we're going to use them. If they're congruent, we're just going to set them equal to each other, and we're going to solve for X. So they're congruent. We set them equal to each other. Here's how I can do this by hand. Now over here, I want to back up and show you this one. The first one's pretty straightforward. You say 2x plus 3 equals 11. I did this one by hand because it was just as easy as typing it into the computer. For example 8, you've got a nasty looking fraction. Okay, so you put this over a 1, And now we're going to cross multiply. You got to be really careful when you're cross multiplying with fractions. You've got to use parentheses. If you leave those parentheses out, you're going to get in trouble. Now, since the x's are all on the top, we probably could just type this in without cross multiplying. Let's give it a go and see what happens. I'm going to zoom. Let's go back to home. What's that x value? Yep, x equals 8.4. Now, that one worked. If it doesn't work, then you have to do the cross multiplying step first. Next examples. Let's see. We're finding the perimeter. So let's erase this here and start over. All right. So this is our last two examples. I got to find the perimeter. I have no idea what these measures are. Yes, you do. Let's look at it. Here's CD. Okay. Look. That green line and this green line are going to be what? Congruent. Yeah, they're going to be congruent. So that means that that piece is 12. Now, let's look here. 10. Oh, yeah, those two pieces are going to be congruent. And then the last piece. Well, yeah, they should be congruent too. All right, those pieces are congruent according to that ice cream theorem we just talked about. What's perimeter? All the sides added together. Add it up. So I've got, let's see, I'm going to start up here with 12. So I've got 12 plus 12. Plus 2, plus 2, plus 10, plus 10. So I've got 24, 25, 26, 27, 28. Plus those two are 20, and that's going to be 48. So the perimeter is going to be 48. What's the next one? Circle O is in circumscribed. That just means it's inside of it. PQR. PQR has a perimeter of 88. Uh-oh. So it sounds like there's going to be a piece of information that I don't know. So let's start with my highlighter. So that's going to be 15. And then here's this. That's not what I wanted to do. Let's see. And here's 17, and that's 17. So this one would be 17. Oh, so the one that I'm missing is here in yellow. Okay. Because they used an X there and a Y to label those points, I'm going to use an N and an N. Okay. So those two lengths are equal. So how many of those do I have? I have 2 of them. And what's this going to be? That's going to be 30. And then what would this be? 34. Good job. Equals the perimeter, 88. So now, I'm just going to go ahead and type that one in. So what I'm doing here, let me recap what I'm doing for some of you who got a little lost. I labeled the triangle with what I knew. So I labeled it with, let me recap this, okay? So that side's 15 and this side's 17. I know that because of the given information. These are the sides that I don't know. I know those sides are congruent, though, from the ice cream cone theorem. So 2 of those sides would be 2n. Perimeter is I add all of these up. And what I did is I just made some shortcuts. I said 15 plus 15 was 30, and 17 plus 17 is 34. It's just a little bit less that I have to type in if I combine some of those figures before I go to type them in. Why did I set it equal to 88? That's a good question. Because the perimeter was 88, and when I add all of those sides up, they're going to equal 88. So that's why I set those equal to 88. N equals 12. What was I trying to find? QY. So QY is here, and that's what I have labeled N. So QY is 12. All right, so if you're looking at this slide, there is one more slide that you can ignore. That's this last one. You can ignore this. This assignment is not for you, but I didn't want to erase that assignment because next year I might go back to using that one. So we're done with our notes for today.